Hi everyone, welcome to Exponents, your partner in education. In the part 3 of Arithmetic for GRE GMAT, we'll be talking about the concept of factorial, followed by the concept of cyclicity, exponents and roots. So let's get started with the concept of factorial. Factorial, as many of you would already know, is given as the product of consecutive natural numbers starting from 1 to the number itself. So if I have to find out 5 factorial, I'll start from 1, I'll keep on multiplying all the consecutive natural numbers till I reach n. So that is the definition of factorial. An important thing to keep into consideration is the value of 0 factorial is 1. The value of 1 factorial is also equal to 1. And n factorial can be written as n into n minus 1 factorial. Now what does this mean? I can combine this thing up and I can write 5 factorial as 5 into 4 factorial. So n factorial can be written as n into n minus 1 factorial. Highest power of a given number that completely divides factorial of another number. So in general, the questions that you have are on finding out the highest power of a given number that completely divides factorial. So for example, if the question is, what power of 2 divides n factorial completely? This n could be anything. Completely divide means my numerator should be a multiple of denominator, or denominator should be a factor of numerator, or I can say that the remainder is 0. Now for example, I see what is the highest power of 5 in 8 factorial. That is the question that I have. So what I'm looking at is, if I write down 8 factorial as 1 into 2 into 3 into 4 into 5 into 6 into 7 and into 8, and look at all 5s. There's only one 5 that I have. So if I have to divide it with 5, I can only divide it with 1. This the highest power of 5 in 8 factorial is 1. Similarly, if I have to find the highest power of 2, I'll try to club all the 2's. I have 1, 2, I have 2 2's, I have another 2, I have 3. So I have 3, I have 1, I have 2 and I have 1. So if I combine them, I have total of 7 2's. So that means the highest power of 2 in 8 factorial, or the highest power of 2 that completely divides 8 factorial, is 7. Similarly, if I have to find out the highest power of 3, I'll combine all the multiples of 3. One is 3 alone, another one is 6. So this is 3 into 1, 3 into 2. There are 2 3's that I have. The highest power of 3 would come out to be 2. Moving ahead, factorial, as you already understand, I am looking at the examples now. 42 factorial, I have to find the highest power of 2, highest power of 3, highest power of 5 and highest power of 6. Now, the thing that we have learned in the previous slide was actually what we were doing, we were combining up the things. Now, when I have a number which is 42 factorial, I can't keep on writing it as 42 into 41 into 40 into 39 into 38 into 37 and combining all the prime factors. That will be very, very difficult for me to do. So, we follow the formula. The formula is 42. I will not take the factorial into consideration. I will just divide 42 with 2 to get to a quotient only. So 42 divided by 2 gives me 21. The next thing has to be with the quotient that I have. 21 again has to be divided with 2 to get to the quotient. So 21, this I have 21. 21 divided by 2 gives me a case of 10. Again, I'll continue this thing till the time I get 0. 10 again divided with 2, you will get 5. 5 divided with 2, you will get 2. 2 divided with 2, you will get 1. 1 divided with 2 and a greatest integer function would lead to an answer of 0. So I'll keep on adding all these quotients that I have got to get to a final answer of 39. So the highest power of 2 in 42 factorial is 39. If I have to check with 3, I'll divide 42 with 3. So 42 divided with 3, I will look for again the quotient, or what can I say, greatest integer function. That means I will eliminate any of the decimal part that I will be left with. So 42 divided by 13, it is completely divisible. I am getting 14. Now the next part would be 14 divided with 3. I'll have 4. 4 divided with 3, I'll have 1. So I'll keep on adding the thing till the time I get to the things. So similarly, I can find it for 5. Now, when I'm coming to 6, 6 is not a prime number. 6 is composed of 2 and 3. So what I'll do is I'll try to break down the question and find out the highest power of 2 and find out the highest power of 3. Since I know the highest power of 2 is 39 and the highest power of 3 is 19, I would look at both of these powers, and now 6 can only be combined, 6 can only be formed when I multiply 2 with 3. There's a limitation on the number of 3's. The number of 3's are less than the number of 2's. So the minimum of the highest power of 2 and 3 would give me my answer, which is coming out to be 19 in this case. Another application of factorial is to find out the number of zeros at the end of a factorial. Now, number of zeros is what? The power of 10. 10 again being a composite number has to be broken into two prime factors which are co-prime to each other, 2 and 5. So I'll find out the highest power of 2, I'll find out the highest power of 5, and whatever is the minimum of these highest power will be the maximum power of 10 that I will have at the end of 42 factorial, or the number of zeros at the end of 42 factorial. So if I look at 2, this is 39. If I look at 5, this is 9. So what is the minimum? 9. There will be 9 zeros at the end of 42 factorial. Let's look at certain questions related to factorials. 15 factorial divided by 3 raised to power m is an integer. What is the greatest possible value of m? Now, if I look at this question, this means 15 factorial should be completely divisible by 3 raised to power m. That means 15 factorial should be a multiple of 3 raised to power m. The number of 3's in the numerator should be equal to the number of 3's in the denominator. So if I am able to find out the highest power of 3 in 15 factorial, so what I have to do is 15 divided with 3, what do I get? 5. Again 5 divided with 3, I get 1. 1 divided by 3, 0. So 5 plus 1, there are 6. So if I open up 15 factorial, I get 3 raised to power 6 into 2 raised to power something into 7 raised to power something into 5 raised to power something. So if the number has to be completely divisible, the maximum value that m can have should be equal to 6. Let's look at the second question. If n is the least integer greater than 5.3, then n factorial must be least integer greater than 5.3. Greater than 5.3, that means I'm talking about a integer function which gives me an answer of 6. So the value of n coming out to be 6. 6 factorial is divisible by. Now if you look at it, 6 factorial will be 1 into 2 into 3 into 4 into 5 into 6. Now I can just look at the option. It will not be divisible by 7 because I don't have 7 in the numerator. It will not be divisible by 11. It will not be divisible by 13 or 14 because 14 is 7 into 2. I don't have 7. If it's not a multiple of 7, it cannot be a multiple of 14. So the only thing that I am left with is 12. If I divide it with 12, 12 is what? 6 into 2. 6 and 2 gets cancelled out and I get an answer, whatever be the answer. Let's move ahead and let's talk about the second topic, which is the topic of cyclicity. And we'll be talking about unit digit cyclicity here. The concept of cyclicity is used to find out the last digit of any number. So if you have any number and you have to find out the last digit of any number, you can use the concept of cyclicity. An important thing to note is that the unit digit will depend only upon the unit digit of the numbers given. So if I'm finding the unit digit, I will not really concentrate on what is the tens digit, what is the hundred digit. I'll only concentrate on the unit digit of the numbers given. Now, for example, if I have to find out the unit digit of this number, I'm not at all concerned about the tens place or the hundred place digit. I'm only concerned about the units place, which are 7 and 6. So if I have to get the final units place, I will only look at the units place and multiply them. So 7 into 6, 42. I'll get my answer as 2. The last unit digit of this product will be 2. That is it. So let's move ahead and let's find out the unit place of certain numbers. So if you have this into this into this, again, I will not look at the rest part of the number. Ignore it, ignore it. I'll look at 1 into 9, which is 9, 9 into 2, which is 18. So my answer is 8. Again, don't look at the left part of the number. So it is 8 and 7, which is 15. So my answer is 5. Now if you have powers with you, 2897 raised to power 41, 8323 raised to power 27. Again, this is immaterial to me, this is immaterial to me. It will be basically 7 raised to power 41, that is 7 multiplied 41 times plus 3 multiplied 27 times. I need to get the unit digit for this. And I will add them up. This should be a multiply sign and this should be a multiply sign here. And I should multiply them up to get to my answer. So here the concept of cyclicity would come into picture. What is that concept? That we'll just study. The concept is if the units place is 0, raised to power anything, it will always end up in 0. That means it has a cyclicity of 1. If the unit place is 1, raised to power anything or multiplied any number of times, the unit place will still remain 1. That means it has a cyclicity of 1. That means there's no particular pattern which is formed. The only pattern which is formed is 1. So 1 raised to power anything end up in 1. 0 raised to power anything ends up in 0. However, if the last digit is 2, now 2 raised to power certain number would not end up in 2 all the time. It would end up in a pattern like 2, 4, 8, 6. Again it will repeat 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. So 2 raised to power anything would have a pattern which is 2, 4, 8, 6, and it will always repeat it in a cycle with a cycle size or a cyclicity of 4. So after 4 places, the number with the last digits would start repeating itself. Same is the case when we are talking about 3. 3 raised to by anything would either end up in 3 or 9 or 7 or 1. Again, there are 4 options which are available to me for the last place if the number ends up in 3. However, if the number ends up in 4, 4 raised to power 1 is 4, 4 square is 16, 4 cube is again 64, 4 raised to power 4 is again 216. So the last place would be filled in 2 ways, either 4 or 6, giving rise to a cyclicity of 2. I can say 4 raised to power anything odd will end up in 4 and 4 raised to power anything even would end up in 6. There are 2 cases only that I will get. Similarly, if I look for other unit digits like 5, 5 raised to power anything will always end up in 5. Let it be even or odd. I'll really not worry about what are the parts. I'll only look at the unit digit. The unit digit is 5. It will always end up in 5, giving the cyclicity 1. If you have 6, again similar to the rule of 5, 6 raised to power anything would end up in 6, giving rise to a cyclicity of 1. Now the important thing that you need to consider here are if the unit digits are 7 and 8. 7, if the unit digit is 7, raised to power anything would again end up in either 7 or 9 or 3 or 1. 7 raised to power 1 is 7, 7 square 49, 9, 7 cube 343 which is 3, 7 raised to power 4 2401. Again if I find 7 raised to power 5, it will again end up in 7. Therefore, a cyclicity that you need to remember is 4. For 8, last digit would end up in 8, 4, 2 and 6 in this specific pattern only. 8, 4, 2 and 6. 9 and 4 have a similar rule. 9 raised to power anything which is odd will always end up in 9, and 9 raised to power a power which is even will end up in 1. So I have only two options for the last digit. The last digit can either end up in 9 or it can end up in 1, giving rise to a cycle size of 2. So I can snub all of these things and I can write it like this. If the last digit is 0, 1, 5 or 6, it will end up in 0, 1, 5 and 6. Therefore, the cyclicity is 1. If the last digits are 2, 3, 7 and 8, this is the main focus that you have to, 2, 3, 7 and 8, it has a cycle size of 4. And the numbers like 4 and 9 have a cycle size of 2. So 4 and 9, cyclicity of 2. 2, 3, 7, 8, cyclicity of 4, and 0, 1, 5, 6 have a cyclicity of 1. This is a very, very important table that you need to remember while you are doing questions related to cyclicity. Now let's look at a question. Which of the following could be the unit digits of 57 raised to power n, where n is a positive integer? Indicate all such digits. So I have to indicate all of these digits. Now what is it? It is 7. 7 raised to power n. Now if you remember the cycle size of 4, the cycle size of 7, it has 4. 7 raised to power 1, 7 square ends up in 9, 7 cube ends up in 3, 7 raised to power 4 ends up in 1. 7 again, 7, 9, 3, 1. So the last digit could be either 7 or 9 or 3 or 1. So I am indicating all such digits. The number of digits would be 4 because the cycle size for a number that ends with 7 raised to power anything is 4. Let's move to the last topic for this presentation, and the topic is exponents and roots. Now, if you have a power, that power is basically an exponent thing that you have. So you have 2 cube. Here 2 is known as base and this 3 is known as exponent. So exponent is something like x raised to power a. Whereas root is x represented like this, x and this. That means I am taking the eighth root of a. So if I write 2 cube, the value is actually coming out to be 8. If I write 2 1 by 3, it is the third root of 2 that I am taking. So this is an exponent and this is a root that you have. There are certain rules that are related to exponent and roots that you have to always, take into consideration while solving the questions of exponents and root. The first one being, when the bases are same, the powers are added. So if you have something like 2 square into 2 cube, it will be actually 2 plus 3, which is 5. When the bases are same, the powers are added. And if you have x raised to power minus b, this minus thing, if you have a negative power, that negative power can be made positive if you bring the entire thing into numerator. So if you have 2 minus 3, it could be written as 1 over 2 cube, which is what? 1 by 8. So this is how you can write it. Now, when the bases are same and the numbers are in division, we subtract the powers. So if the bases are same and the numbers are in multiplication, you add up the powers. If the bases are the same and the numbers are in division, you will subtract the powers. This will be x a minus b. So if you have something like 2 over 5 over 2 cube, my answer will be 2 square. Most important rule is anything raised to power 0 is 1. So x raised to power 0 is 1. 0 raised to power 0 is undefined that you have. And 0 raised to power anything is always 0. Anything raised to power 0 is 1, but 0 raised to power anything is 0 that you have. Don't get confused between these two things. They are very, very simple, yet people confuse when they get into questions. The next we have is x raised to power a raised to power b. Now here, this b will be multiplied with this a to give you the answer x raised to power a into b. So something like you have 2 cube raised to power 2. It will be 2, 3 into 2, which is 6. Now, an important thing to notice, 2 raised to power 3 raised to power 2 is not equal to 2 raised to power 6, because in this case, this power 2 is only the power of this 3 and is nowhere related to the base. So this 2 here is obviously related to the base. This 2 here is not related to the base. So 2 cube 2 will be equal to square of 3, which will be 2 raised to power 9, and this will not be equal to 2 raised to power 6. So these are the two very important rules that we have to remember. X raised to power a into b, this will be x a raised to power b. So first I'll have to solve this thing, then come back to this. Now the next that you have is x into y raised to power a. This power a is associated with both x and y. So I can split up the power x raised to power a into y raised to power a. So if I have 6 raised to power 10, I can write it as 2 raised to power 10 into 3 raised to power 10, because 6 is 2 into 3. Now if x raised to power a is equal to y raised to power a, that means x has to be equal to y, provided that a is not equal to 0. So if we have 2 raised to power 6 equal to x raised to power 6, that means x has to be equal to 2, provided this a, the power which is there, is not equal to 0. Similarly, if you have x raised to power a equal to x raised to power b, now here the bases are same, that means the powers would also be same. Again, this x should not be equal to 0 or 1, because 0 raised to power anything is 0 and 1 raised to power anything is again 1. So if the bases are same, the powers can be compared. If the powers are same, the bases can be compared. And the last one that you have is x raised to power a over b. I can write it as xa, and this 1 by b can be written as bth root. Or I can bring this b inside and a outside. This will be bth root of x raised to power a. It is one as the same thing. So let's look at some of the questions related to exponents. If x is not equal to 0, then which of the following is equivalent of? This is the question that we have. Now if you look at it, this is x square cube and x square. Now this 3 is related to the entire thing, so it will be x into x, 3 into 2, 6 over x square. Now this I can write it as x7 over x square. I know when the bases are same and they are in division, the powers are subtracted. My answer will be x raised to power 5. Let's look at another question. If n is equal to 2 cube, then n raised to power n is. So what do I have? I have 2 cube raised to power 2 cube. Now this cube is associated with this 2. So it will be 2 cube raised to power 8. Now I'll multiply them. 8 into 3, 24. This is the answer that I'll have. So I'm applying two formulas. One is m into n. That will be equal to xm into n. And one is x raised m. This I have to solve manually. That is not be equal to xm into n. So I'm solving this thing out. 2 cube, which is 8 first. 8 will be multiplied with 3 to get you your answer. So the next question that we have is 2 raised to power x minus 1 plus 2 raised to power x plus 1 is 1280. Then find out the value of x. So I can do this question as the options are given to me by just taking the middle option first. If I take the middle option and if I put it at 2 raised to power 8 plus 2 raised to power 10. If I just solve it, this is 1024 and 2 raised to power 8 would be equal to 256. So if I just solve this thing out, I'm anyways getting 1280. That means this is the answer. However, if I want to solve it manually, I can still do it. This will be 2 raised to power x, 2 raised to power minus 1 plus 2 raised to power x into 2 is 1280. I can take 2 raised to power x common and I can write it as 1 by 2 plus 1 is equal to 1280. Again, 2 raised to power x into 2.5 is equal to 1280. So if I just divide it, I get the value for 2 raised to power x is equal to 512. So once I get it, the value of x comes out to be equal to 9. Let's look at another question. The question is 2 raised to power n plus 2 raised to power n minus 1, 2 raised to power n plus 1 minus 2 raised to power n is equal to. That is the question that you have. So again, if I write it as 2 raised to power n plus 2 raised to power n over 2 over 2 raised to power n into 2 minus 2 raised to power n. I can take 2 raised to power n common from numerator and denominator, and that will be cancelled out. This will be 2 minus, very simple, 2 raised to power n cancelled out. This is 2.5 over 1. The answer is 2.5, which is equal to 5 by 2. Let's look at another question. The question is, find the largest among them. So you have 3 values which are given to me. One thing is, if you have a scientific calculator available with you, you can obviously solve this thing out. So there is nothing really big in this question. But if you want to learn the method, what we do is we try to look at the powers and try to make them same. So this is 1 by 4, this is 1 by 2, this is 1 by 3. So I have 4, 3 and 2. I will find out their LCM. So if I try to find out the LCM comes out to be 12. I'll try to make everything in the powers of 12. So if you have this thing, if you have 6 and what I have the 4th root of it. So what I'll try to do is, if I just look at it, this is 6, 1 by 4. This is 2, 1 by 2, and this is 4, 1 by 3. So what I'll try to do is, I'll try to make the outside power as 1 by 12. This will be 3 and 12 will get cancelled out to give you 4. This will be 2 raised to power 6 and 1 by 12. This will be 4 raised to power 4 and 1 by 12. So if I just solve it out, 6 cube, 216, 2 raised to power 6. 2 raised to power 6 is coming out to be 64. 4 raised to power 4. 16, basically it will be 64 into 4. That will be the answer that I will have. So the question is asking me which of the following is the greatest. Now if your bases are same, you can compare the powers, or if your powers are same, you can compare the bases. So if you just look at this, this will be 4 cube. This is 6 cube. This is 4 raised to power 4. 4 raised to power 4 turns out to be the greatest that we have. Let's look at another question. The question is, you have to solve this thing out. So whenever we have a question of this type, we'll always solve from the inside and come to the outside. So this will, if I solve root 9, this will be 3. 19 minus 3 is 16 and root of that is 4. So I'll just do that. This is 25, root of that is 5. So if I just look at this, 41 minus, 21 plus 4 is 25, root of which is 5, and this is coming out to be 36, root of which is 6. So this is the answer that I have. Other question that we have is 15x is equal to root of 735y. Where x and y are integers, what is the least possible value of x plus y? This is the question that we have. Here x and y have to be integers, and it is 15x that you have on this side. So what you can do is, you can try to find out what is the square root of 735. I know exact square root of 735 is not possible, but still I have to break it down. So this will be 15x is equal to, I'll have to prime factorize 735, because I'll have to compare both the sides, and I will then find out what is the value that the given variables x and y can take. So if I just start with 735, divide it with 5, I get 147. 147, if I look at it, 147. Now 147, is it a prime number or not? It will be 5 into 147 into y and square root of it. Now I have a doubt of 147, whether it being a prime number or not. So I'll apply the divisibility rule. This is not divisible by 2. So leave it. 7, if I just look at the sum of the digits, the sum of the digits is coming out to be 12. So that means it is divisible by 3. So I'll just break it down, 5 into 3. Now what is it? 49. 49 is 7 square. This is the prime factorization that we have for this thing. Now if I look at it, 1 7 can be brought out, and inside I'll be left with 5 into 3 into y, and this is 15x. Now I have to find out the least possible value of x and y. So that means here I have 7, but on the left hand side there is no multiple of 7 that I have. That means x has to be a multiple of 7. What about this side? You have 15. I will not be able to make 15. So the value of y has to be at least 5 into 3, so that 5 and 3 comes out. So the value of y has to be 15 and the value of x has to be a minimum of 7, giving me an answer of 15 plus 7 as 22. Let's look at another question. The question is, find what is the greatest prime factor of 2 raised to the power 99 minus 2 raised to the power 96. Now I can take 2 raised to the power 96 common. Now if I just look at it, this will be 2 cube, because when bases are same, powers are added, minus 1. 2 raised to the power 96 into this will be 7. So if I look at the prime factor, it will start with the prime factor is 1, 2, 7, and then all the other factors that you would get would be a composite factor. So the greatest prime factor for this is 7. You can also look at this chart, and this chart helps you in finding out the square and cubes of number. Till 20 you have squares, and till 10 you have cube. You have powers of 2 in this table. You can keep it as your reference table. You have powers of 2 and you have powers of 3. It's very easy to solve a question if you have looked at these powers at some time or the other. We hope you have enjoyed this video. Please like our video and subscribe to our channel on YouTube. You can visit our website edusathi.com to practice more questions on this topic and access other useful information. Like us and follow us on Facebook and Twitter to get exam related information and other such updates. We wish you all the best for your preparations. Thank you and have a good day.